Hello, my name is KUMAR and I'm from RY40. My metric number is 191382078. So today I'm going to give an explanation on electronic analog circuit F5 active filter, and it is based on low pass filter and also high pass filter. So we move on to the objective. First of all, to demonstrate the use of operational amplifier in active filters. And next is to build an analysis of the SARHAN key, second order low and high pass filters design. Okay, this is the introduction of it. This is the example of second order low pass filter and also second order high pass filter with the table related expressions. And the design would be done in multisim. Okay, as for the first low pass filter, the procedure is calculate and record in table 4 the theoretical cutoff frequency and the output voltage at the cutoff frequency Vout for second order low pass filter shown in figure 3. So we need to use 1 BP sine wave with frequency 1 kHz. And as for high pass filter, same as the low pass filter, calculate and record in table 6 the theoretical cutoff frequency and also output voltage for the second order low pass filter. And as for this, we need to use input of 2 VP at frequency 25 kHz. Okay, first of all, this is the result for low pass filter, active low pass filter SARHAN key, and the value has been calculated through a formula that is 1 over 2 pi square root of R1 times by R2 times by C1 and C2. So I got this 2.38 kilohertz. As for this value, I should multiply by the value of 2.38. So 1 over 12 times by 2.38 kilohertz. So I got these values here, and also times we need to multiply it by the 2.38. So as for the V in, it is constant as from the procedure, that is 2 voltage. To find out the V out, we need to see the design that we did in multisim. So as you can see, this is the circuit design that I did in multisim, and the value I've put is 2.38 kilohertz for the frequency. So the blue color in the waveform shows the output. So the value shows here is negative 1.4571 voltage. So as for Vout, we need to replace with the value of the frequency that we get from here into the circuit to find out the Vout. As for the voltage gain, it should be calculated from the formula given here, that is Vout over Vin. As for the voltage gain AdB, that is 20 log ACL, that is 20 log gain. So this is the value I got from the calculation here. As you can see, this is the low pass active filter graph, that is voltage gain versus frequency. So as for the pass band, it shows in the black mark, that refers to the pass band. And as for the response, it is fallen under 0 beyond the pass band. Next, it's a high pass active filter. So it is calculated same as the low pass active filter, that is 1 over 2 pi square root of R1, R2, C1 and C2. So the value that we got is 1.13 kilohertz. If you multiply it by the value that is given, so you might get 141.25 hertz, and as for this 282.5 hertz, and you can see the values here: 555, the same value, 1.13, 4.52, and so on. As for V in, it is constant that you saw from the procedure just now, that is 2 voltage. So as for V out, we need to find out from the multisim. So as you can see, this is for the high pass filter, and this is the circuit design. So I changed the value for 1.13 kilohertz. So the blue color refers to the output. uh, as you can see down here, the value of output is negative 1.433 voltage. So as for VR, we should be replaced from the frequency to the circuit. Need to replace the values that has been given here, uh, so you might get the V out. As for gain, we should use the formula, and also for the ADB, we need to use the formula given here, that is 20 log ACL. So this is the result that I get for high active. So this is the graph that I plotted for voltage gain versus frequency high pass filter. As for the place where the black mark is, the ideal response, it shows the ideal response. The instantaneous drop at critical frequency which are not achievable. Ideally, the pass band of high pass filter is all frequencies above the critical frequency. Due to that, it's called a high pass filter. So as for the conclusion, from this experiment, we are providing the theory of the characteristic of filter. Low pass filter allows frequency lower than the cutoff frequency, while high pass filter allows frequency higher than the cutoff frequency. In conclusion, by completing this lab, we are able to achieve our objective of this lab by able to demonstrate the use of operational amplifier in active filters. Hence, we are also able to achieve to build and analyze the SARHAN key second order low and high pass filter design. So I am ending the session here, and thank you.